the question, how can one element be so different? We're talking about that element oxygen and its two allotropic forms. Okay, so we're going to take a closer look at Lewis structures. This is a technique that is used by chemists to figure out or model what is bound to what, or predict, I should say, what atom is bound to what atom in a molecule. And so last time we recognized that the periodic table is arranged in this way that the properties repeat each other in a periodic fashion within groups, and the thing is that the electronic structure is changing as you move across the periodic table in a periodic way. And as it turns out, one of the defining rules to help us predict the type of bond that's going to form is the octet rule. And we saw the octet rule even in the ionic compounds where electrons are being lost or gained to try to satisfy what we call the octet, which is to have 8 electrons in that valence shell. There's something very stable about that. So atoms will just do what they can to rearrange themselves with other atoms. There's this like driving force to achieve an octet. And so in the case of the ionic compounds, we saw that is achieved by gaining or losing electrons and setting up little charged atoms called ions. But in the case of covalent compounds, which is what we see when we combine nonmetals with nonmetals, we achieve an octet by sharing electrons. All right. So in the Lewis structure, the bonding pairs, this is a review from the end of the last lecture. In the Lewis structure, the bonding pairs are a dash, and the non-bonding pairs we will leave just as dots. Okay, and then the atom is the elemental symbol. Now, in this particular example, methane, and ignore this number shouldn't be here. In methane, you've memorized this. Methane is the chemical symbol CH4. Okay, and you may, this is the way that these covalent bonds are formed. Now, when I of course look at this, let's see, when I look at this bond, okay, let me draw something. Let me see. Okay, when I use my eyes to look at that bond, I'm looking. What I'm thinking is that dash means a shared pair of electrons. And you have to get to that point too, that when you see something like this, it's not just letters and dashes and other letters, but this is a carbon atom, and there is a pair of electrons, and here we've modeled it here with 2 dots, existing largely between these 2 atoms, and so they're shared by both atoms. And so when I count up how many electrons are in the valence shell of carbon in this particular molecule, I'm counting 2, 4, 6, 8. When I count up how many electrons are next to this particular hydrogen, I see 2. And so I can see, oh, this is a stable structure because the octet is satisfied. But how did I know to arrange it this way with the carbon in the middle and the 4 hydrogens on the outside? If I see this, or if you see this CH4, why isn't it just this? Okay, why isn't that the structure? Okay, so there's something about the Lewis structures that we can predict that indeed this is not the way the molecule is arranged, but rather this is the way the molecule is arranged. So we want to get to the point where I can give you a molecular formula, and you can correctly predict what atom is bound to what atom and what type of covalent bond is between those atoms.